And this one is from our friends north of the border, Creaform. This is the HandySCAN 700 that Dirk is going to look at now. So Dirk, you're finished walking over to our set, so take it away.
It was a long walk, let me tell you. Okay, Mike, thanks a lot. Yeah, as Mike said, we're going to look at the HandySCAN 700 from Creaform up there just outside Quebec and Lévis. This is actually, the HandySCAN 700 is the highest end scanner that Creaform makes. It's very accurate, very fast. This is a metrology grade 3D scanner. We're talking 30 microns accuracy. Collects about 500,000 points per second. And when we're talking about speed, just to give you an idea, they recently scanned the entire hood of a Mustang in 30 seconds. So if you think about it, that's just about as fast as you can move this across the entire hood of a car, right, of a Mustang, and collect all that data. And remember, still, even scanning that fast, still at an accuracy of about an accuracy of 30 microns. So very accurate. And the other thing about the HandySCAN product line, if you're not familiar with it, is they scan direct to mesh. There is no point cloud. I call it gun and run. You can just scan something, export the file, you're done. As I'm scanning, it's creating a mesh, and that mesh can be immediately exported without any post-processing, something that you don't get with let's say, a point cloud. And this will be very important, and you'll see why in just a little bit. So let's talk about let's actually talk about the HandySCAN 700 just a little bit. If we can go to the gauge cam here. Let me just point out a few things. The back is very simple. We've got our little button here to start the scan. We've got a couple of up and down buttons to control either zooming in and zooming out on the screen, or to control the shutter speed of the camera itself. And then we've got a little button up here that toggles between those two modes. On the front side here, we've got the two cameras, and the laser projection is right out here in the middle. So we're going to go ahead and set it for a scan and do that really quick. If we go to our screen share, I'm just going to tell scanner config, and the first thing I want to do is I need to configure this for the reflectivity of the object we're going to look at. Now I could do this manually, but I'm simply going to do auto adjust because that works pretty darn well. And that's all it takes. We're ready to go. The other thing I can look at is the scan resolution. Now right now the resolution is set to 1 millimeter. I could go down to 50 microns. Takes it longer to process if I do that, so I'm going to keep it at 1 millimeter. And that's all there is to it. We're going to get ready for a scan. So if we just come back here to the gauge cam. Now notice, I'm going to pick up my object here. So notice, I'm actually holding my object. I got my object in my left hand. I've got the scanner in the right. Guess what? There's no fixturing, right? Both of these things are going to be moving all over the place, and yet I'm going to be scanning to an accuracy of 30 microns. Also notice that there are targets on this. This product does require targets on the object. There's another product that we're going to look at next week, the GoScan, which does not require targets, but it's not as accurate. So if you need that accuracy, you're going to want to use the HandySCAN 700 and put targets on your product. So I'm going to go ahead and start doing a quick scan. Now if we go to our screen share, you can see here I am collecting my data, and you can see I'm just kind of moving this around, collecting the data, and I could keep going like this, but it's actually easier. I just want to show you that I can do this. It's actually easier if I go ahead and now set this down on the table, and the rotary table, and do it that way. But as you can see, I was just moving that around and doing it that way. Now, notice off to the left-hand side, if we go back to screen share, you see a little color bar. All that's telling me, that's a visual indication that I am at the right offset distance on the object. If it's in the green, I'm in the right. If I'm too close, it turns red. If I'm too far away, it turns blue. So I want to stay kind of in this green area as I continue to scan. And also this visual indication, if we can go to the gauge cam here really quick, the visual indication is also here on the back. This LED will turn colors as I get too close or too far away. Red if I get too close, blue if I get too far away. Okay, and let's go ahead and stay on this. If you notice right now, the type of laser scanning it's doing is a 7-segment cross. That means there's 7 lasers going this direction, 7 lasers going that direction to create kind of a cross on there. Allows you to scan large areas quickly. I can very quickly switch now to a laser line scan. A laser line scan allows me to get down deep into holes or into features that may not be accessible if I'm doing the 7 laser cross. So this allows me to get right down into holes. So again, very quickly to switch back and forth. And now I'm back into this mode. So let's go ahead and stop our scan here for a second and take a look at what we got. So I'm going to take a quick look at this and see if I scanned everything. Well, it looks like I missed some areas. Yeah, look at that. I kind of missed this whole area back here. So now if I was collecting point cloud data, I would have to start a scan again, then align those point clouds. I don't have to do that. I can just say, oops, I'm sorry, I stopped the scan. We'll go back here in a second. All I have to do is start the scan again. There we go. And I'll just go back and pick up those points that I missed. So now I can just come over here and I can scan that area where I missed before. And what's happening is the HandySCAN and the software are recognizing it's recognizing what the HandySCAN is currently seeing versus what's already stored, doing that alignment on the fly, and no alignment is required. It just simply goes back in and starts scanning where you left off, and that's all there is to it. We'll go ahead and stop. We'll assume I've scanned everything. I'm going to stop my scan. Now what it's going to do, we're actually done. I could export this right now and be done with it. But maybe I want to do a little bit of cleanup. I don't want to pass this scan on to somebody else when there's maybe outliers sitting on there. So I want to do a little cleanup. There's some really good automated tools in VX Elements, the software, as well as some manual editing tools. We're going to take a look at a couple of the automated ones. First of all, I got a slider, remove isolated patches. This takes out areas that are discontiguous from the main body of the scan. So if you notice, if I turn the filter off, you'll see some stuff shows up there. As I start to move this over, it gets rid of some more. I also want to get rid of the turntable that's on there, so I am going to use clipping panes. I'm going to add actually that plane simply by selecting 3 points. If I do this right, selecting 3 points on the plane. There we go. I'm also going to do a little adjustment on that plane and say apply, and that will get rid of now that plane that was underneath our object, which was actually simply the rotary table. So now when I'm done, what I should have is actually a pretty clean scan of the object ready to export. So it'll just take a second here while it renders this, and we'll be able to take a look at that. All right. And any second now. There we go. So, and then you see is our completed scan. So you notice there's no artifacts outside of the scan itself. You can see a couple holes. If I wanted to, like I said, I could go back in and fill those in very quickly. But essentially, we're done. This was gun it and run. So all I have to do right now is say scan, save mesh, and I could go ahead and output this right now. I could output it as, let's say, an STL file, an ASCII STL, 3D points text, any of a number of about a dozen different types of file types, and that's it. That's all there was to it. There was no post-processing. In fact, like I said, if I didn't want to, I could have just scanned this and exported it right away, and that would have been the end of it. So, again, this is the HandySCAN 700 from Creaform. Thanks, guys. This is a metrology-grade scanner. Remember, 30 microns accuracy and very fast. Thanks to the guys up there at Creaform for sending this to us. Dan, Francois, David, Emily, merci pour le HandySCAN. Au fait, j'aime la pierre, la fin du monde. Just saying. Thanks, Mike. Back to you.
Yeah, I got all that, Dirk. Thank you.